Hey guys, I'm Jed. Welcome to my LeetCode Review One Take vlog on the 46th problem, Permutations. We are given an array, nums, of distinct integers. We'll return all the possible permutations. We can return the answer in any order. Then let's see the example 1 here. We got empty nums array, 1, 2, 3. And all the possible permutations are 1, 2, 3, 1, 3, 2, 2, 3, 1, and so on. Then, let's get into the intuition of this problem. When we see a problem asking for all possible arrangements, our mind immediately goes to backchecking. The key steps of backchecking are choose, explore, and backcheck. We choose a number for the current position. For example, we pick 1 from 1 to 3. Then, we recursively explore the possibilities for the next position, such as we can pick 2 or 3 in the second position. And then, we backcheck by removing that number to try a different choice for the current position. To avoid using the same number twice in one permutation, we'll need to keep track of which numbers have already been included. Therefore, we can think of 2 ways to approach this problem. The first approach, brute force. We could try to generate all possible sequences with length n and then filter out invalid permutations which contain duplicate numbers. But this method would be highly inefficient. Or the second approach, backchecking. It builds only valid permutations, avoiding redundant work. Let's proceed with the backchecking approach, as is a clean and optimal way to solve this. First, we create a list to store all the final permutations. List of integers called, let's say, result. Oops. Gets a new empty array list. Then we create a Boolean array to keep track of which numbers from the input array have been used in the current permutation, and the index of this array will correspond to the index in the nums array. Boolean array called used gets new Boolean array of nums.length. Then we'll start our recursive helper method, which we'll call backcheck. We'll pass the final result list, a new empty list to build the current permutation, and original numbers, and a used checker. We'll implement the backcheck method in the following code. Backcheck of result list, new empty array list, to build the new permutation. The third parameter is the nums array, and the fourth parameter is the used tracker. Finally, after recursion have explored all the possibilities, we just return the populate list of the results. Alright, next, let's implement the recursive backcheck method. It builds the permutations state by state. Private void backcheck with 4 parameters. The first parameter is list of integer called result. The second parameter is list of integer named, let's say, current permutation. The third parameter is integer array named nums. And the final parameter is Boolean array named used. Next, let's implement the backtrack method. Every good recursive method needs a base case to know when to stop. Here, our base case is when the permutation we're building is the same size as the input array. If so, we formed a complete valid permutations. So we need to return. The code is if current permutation dot size equals nums dot length. At this point, we need to add a copy of it to our final result list. It is very important to add a copy because current permutation variable will be modified as we backtrack of the recursion tree. And the corresponding code is result.add of new array list of current permutation. After adding the result, we're done with the specific recursive path. So we just return. Otherwise, if their size doesn't match, we'll explore our choices for the next number in the permutation. We'll implement a for loop to iterate through all the numbers in original input array. For integer I started at 0 when I is less than nums.length. We'll continue the for loop. After each iteration, we'll increment the I variable. For each iteration, we have a check at first. If the number at index I has already been used in this path, we simply skip it and continue to the next number to avoid duplicates in the permutation. If used Boolean array of I is true, then we'll continue the for loop. On the other hand, if the number is available, we add it to our current permutation. Dot add of nums of I. Then we mark this number as used to avoid duplicates in the subsequent recursive calls. Used of I gets true. Now we need to explore. We make a recursive call to the same method to continue building the permutation from here. We'll recursively call backtrack method with 4 parameters: result, current permutation, nums, and used array. After the recursive call above returns, it means we have fully explored that path. We now need to backtrack our choice so we can explore other paths. But first, we need to unmark the number as unused. Used of I gets false. Then, we'll remove the number from the end of our current permutation list. This takes us back to the previous state, allowing the loop to continue and try the next number. Current permutation dot remove of current permutation dot size -1. Okay, that's our implementation. Let's run it against the test cases. Yes, it got accepted. Let's break down the time and space complexity analysis. The time and space complexity. So the time complexity, it is big O of n factorial times n. And there are several factors. First, the number of permutations for an array of n distinct elements is n factorial. Second, our backtracking algorithm generates each of these permutations exactly once. Third, for each permutation, we do n amount of work to build it. We add n elements to the list and create a final copy. Therefore, the total time complexity is big O of n factorial times n. And the space complexity would be big O of n, or big O of n factorial times n. First, the primary space usage comes from the recursion stack, and the maximum depth of the recursion will be n. We also used a Boolean array of size n and the current permutation list, which stores up to n elements. So all of these are related to n, and auxiliary space complexity, it is big O of n. If we include output list, the space would be big O of n factorial times n. Alright, this is the end of my LeetCode Review one-take blog on the 46th problem, permutations. And I highly recommend you guys to visit my online GitHub page here, which contains all the problem description, intuition, code walkthrough with detailed annotations, and the final complexity analysis. You can also visit my GitHub repository here, which contains all the code and notes to build this online GitHub page. I'll put those two links on my YouTube description below. And see you guys next time. Bye bye.